Resolution. Why do we use microscopes? Well, the reason is that they give us really good resolution. But what is resolution? Resolution is the ability to distinguish between two adjacent and separate points or objects. So imagine you're looking at two tiny specks of dust, and it's really difficult to tell them apart. Is it one piece of dust or two pieces of dust that are really very close together? And the reason we have difficulty telling that is that our eyes only have a resolution down to about a fifth of a millimetre. And that means anything closer together than that we cannot see as separate objects. It's important to distinguish between resolution and magnification. As I've said, resolution is the ability to differentiate between two structures that are close together. Magnification is just making things big. So it's important that you resolve things first and then you can magnify them rather than the other way around. And we have quite a good demonstration of this with this funny little Victorian slide, which was sold as a curiosity, and it's a glass slide that you put under the microscope, and it's called Eminent Men. And that tiny little grey area in the centre of the slide is the bit that we're looking at. If we scan that slide with a flatbed scanner on a computer, we can magnify it, but we're not resolving the detail in it. We have to use something that will resolve the detail, and that thing obviously is a microscope. And when we do that at ×4 magnification, you can see all these little heads pop out at you. So these are what the Victorians thought were the 100 most eminent men over time. There's Shakespeare right in the middle there. There's Walter Raleigh, and then there's Leonardo da Vinci. See how many you can spot. Anyway, we can resolve the features on the faces. If we go up to ×10 magnification, we can resolve even more detail on their faces, their expressions, their beards, their hair, and also you can start to see the background silver grains that go to make up the image. If we go up to ×20 magnification, we aren't resolving any more detail in the faces because there isn't any more detail to be had. We're just making it bigger. But we are starting to resolve the silver grains that make up the background of the image. And then if we go up to ×40 magnification, again, no more detail in the faces to be seen. And actually, we can't resolve the silver grains anymore. We're just making it bigger. So we're magnifying it, but not resolving any more detail, which is known as hollow magnification. So if we look at our microscopes, we can see what kind of resolution they can attain. As I said, the human eye can resolve things down to 200 microns, which is a fifth of a millimetre. A light microscope can do 1,000 times better than that and resolve things down to 200 nanometers, which is a fifth of a micrometre. X-ray microscopes, 50 nanometers, scanning electron microscopes down to 5 nanometers, and transmission electron microscopes are really the best of all, and they have a resolution of 0.2 of a nanometer. And there are transmission electron microscopes around now that can do a factor of 10 better than that. So that's 0.02 of a nanometer, and they can image atoms.